The line integral. Now, how do we express the displacement vector in curvilinear coordinates? Using multivariable calculus, we know that this displacement vector is partial derivative of the position vector with respect to the coordinate qi multiplied by dqi. Now, we know that the magnitude of this is the scale factor hi. So we can recall the magnitude corresponding to the coordinate qi, del r del qi scale factor. So if I divide this by the scale factor, I obtain the unit vector. So if I multiply the unit vector with this, I'm going to obtain del r del qi. Therefore, I'm going to substitute here for del r del qi the scale factor hi dqi in qi hat direction. So qi hat is this divided by hi. So hi's will cancel, you will obtain the original form. Okay, so once we know how to write the displacement vector, differential displacement vector, we can perform a line integral over a contour dr dot product with the vector v. This is going to be a contour integral dqi hi qi hat dot product with vj qj hat. So this is our vector v written in terms of its components in the curvilinear coordinate system. And because the unit vectors form an orthonormal set, we have dqi hi vj delta I j. So I is equal to j. So that's what we have to do. And therefore, we obtain our final form. The contour integral dr dot v is dqi hi vi. So we have to take the ith component of the vector v in the curvilinear coordinate system. So we started out by writing the displacement vector in curvilinear coordinates. We take a partial derivative of the position vector with respect to qi and multiply it by dqi. This is how we express the differential displacement vector in multivariable calculus. So this is actually a summation over I. And for del r del qi, I can replace it by the unit vector qi hat multiplied with the scale factor magnitude of del r del qi. Since the unit vector qi hat is given by the magnitude del r del qi divided by its magnitude, so that it has a magnitude of 1. And then the line integral becomes the contour integral dr dot v dqi hi qi hat dot product with vj qj hat, the vector v written in the curvilinear coordinate system. And because these two vectors are orthonormal, the dot product is delta ij. Kronecker delta ij sets j is equal to I. Therefore, our answer is dqi hi vi integrated over this contour.